Hess's law. Okay. Hess's law states that the energy change in an overall chemical reaction is equal to the sum of the energy change in the individual reaction, right, in this case. In other words, regardless of the route by which chemical change occurs, provided that the initial and the final condition are the same, the enthalpy change for a reaction is the same whether it occurs by one step or by any series of steps. This experiment involved 3 reactions. Reaction number 1 between the sodium hydroxide and water. Reaction number 2 between sodium hydroxide and hydrochloric acid solution. And reaction number 3 between the sodium hydroxide solution and hydrochloric acid solution. Okay. So, in reaction number 1, we measure out, we place 200 ml of the water in the calorimeter. Then we take the initial temperature of water. Okay, we take the temperature of water, that is initial temperature. Then we add approximately 4 grams of sodium hydroxide. Okay, mix in with the water, stir it, and check the temperature again. This temperature is a final temperature, the temperature of the mixture. Okay. So the difference between initial and final will be your delta T in this case. If you know the mass of the reaction mixture, in this case, mass of the sodium hydroxide that you use, plus mass of water. Now you place 200 ml of water, but the density of water is 1 grams per ml. So 200 ml of water is the same as 200 grams of water. Right? The sum of sodium hydroxide, mass of sodium hydroxide, and mass of water will give you mass of the reaction mixture. Specific heat of water is 4.184 joule, and the changing in temperature you obtain from this experiment. Okay. Reaction number 2 and 3 follow similar procedure. Okay. Then the next question, the goal is first is to determine the enthalpy heat of reactions for all 3 reactions. Okay, reaction 1, reaction 2, and reaction 3. Then we will verify the Hess's law by showing that the heat of reaction or enthalpy of reactions, okay, from the reaction 1 plus reaction 3 is the same or equal to the enthalpy of reaction for the reaction number 2. Okay. Then we calculate the percent difference between the enthalpy of reaction for reaction 2 and enthalpy of reaction of 1 plus reaction 3, 1 and 3. Okay. This table, okay, so we start experiment, you collect data, your mass of sodium hydroxide, you weigh it out and record everything you read on the from the balance display. Okay. Notice that sodium hydroxide in reaction 1 is solid. Reaction 2 also solid, but reaction 3 is liquid. Okay, liquid. The procedure asks you to place 100 ml of 1.0 mole of sodium hydroxide. So we assume that the density of the sodium hydroxide solution also 1:1 in the 1 grams per ml. So you have 100 ml. This means it is 100 grams of sodium hydroxide. I'm going to give you some example. For example, the mass of my sodium hydroxide, I get 3.823 gram. Yours will be different. Okay. They asked me to calculate mass of the reaction mixture in each reaction. Example, reaction 1, mass of the reaction mixture is mass of sodium hydroxide in reaction 1 plus mass of water. mass of sodium hydroxide in reaction 1. Okay, I used 3.823 grams, and then mass of water in this case 200 grams. So come out to 203.823 grams for reaction 1. This is example. You can do the same thing for your reaction 1, reaction 2, and reaction 3. Now reaction 3 is, one thing is, you're dealing with liquid. They're both in aqueous solution, in aqueous form. We assume that the density of sodium hydroxide and solution and density of the hydrochloric acid solution is about 1 grams per ml. Okay. So if you put 100 ml of the sodium hydroxide solution, it will be about 100 grams. 100 ml of hydrochloric acid will be about 100 grams also of hydrochloric acid. Next question, number 12, they ask you to calculate the total heat released in each equation. In other words, they ask you to calculate enthalpy of reaction. Okay, for each reaction, they ask you to express that in joule. Okay, so in order to get this to calculate heat of reaction, you need to know mass of the reaction mixture. Okay. You need to know the specific heat, which is 4.184 joule, and you need to know the changing in temperature, okay, of the reaction. Now let me give you example of my reaction number 1. My mass, okay, is 203.823 grams. Okay, this number I obtained from number 11, multiplied by 4.184 joule, multiplied by changing in energy. This is example 5.02 Kelvin. Now yours gonna be different. Okay, you multiply all this together, I got 4,281.03 joule. Number 13, calculate the number of mole of sodium hydroxide used in reaction 1 and 2. So only reaction 1 and 2 because these two are solid. So if you have solid sodium hydroxide, you can calculate mole if you know the molar mass. So mass of sodium hydroxide divided by molar mass of sodium hydroxide give you number of mole. Okay, example, my reaction 1, I used 3.823 grams of sodium hydroxide. Molar mass of sodium hydroxide is 40.0 grams. So my mole of sodium hydroxide is 0.095575 mole. And you do the same thing for reaction number 2. Okay, same step. Number 14, calculate the number of mole of sodium hydroxide used in this reaction. Okay. To do this in reaction number 3. So to calculate number of mole of sodium hydroxide, okay, is equal to molarity multiplied by volume. Okay. So it is in step number 9, they tell you that the concentration of sodium hydroxide is 1.000 mole. So this is 1.00 multiplied by the volume. The volume that you put in the beaker is 100 ml. So now you have to convert from milliliter to liter in order to use this formula. Okay. Next, number 15. Number 15. So calculate the energy released in kilojoule per mole of sodium hydroxide. Okay. So first you have to convert the heat of reaction from number 13 and 14. Number 12. Okay. From number 12, that you calculate from number 12, from joule to kilojoule, and then divided by the number of mole of sodium hydroxide. Okay. For example, the heat of reaction number 1, here in my case I got 4,281.03 joule, and number of mole of the sodium hydroxide is 0.095575 mole. So you convert from joule to mole, and then divide it by, convert from joule to kilojoule, and then divide it by number of mole. You get 44.79 kilojoule. Okay. Number 16, you show that equation reaction 1 plus 3 will give you the same equation for reaction number 2. That's what Hess's law said. You can the reaction can go only one step, or you can use a series of steps. So you're going to add these two equations together. One thing you're going to do, you're going to change this to number, the actual number. Okay. For example, for me, this number will be 44.79 joules. Okay, the example. So let's see. So 44.79. So instead of this, I will put down 44.79 joule. And when I complete number 3, I would do the same thing. I convert from I substitute this with the actual number. Okay, then you add. Okay, so you have add NaOH plus Na plus OH minus, okay, plus hydrogen plus Cl, okay, yield, same thing. So you put Na plus OH plus H2O plus Na plus Cl minus. Okay, and you add these two numbers together. Okay, you get one number. So let's take a look. This cancel. Now next one you have. Okay, so this equation you can verify that it's the same as the equation from reaction number 2. Then you can compare the number. So you already calculate this one from the previous problem. Okay, so you have the actual number here, and then you can compare them. Then find the percent difference between these two numbers. Okay, if you have any questions, let me know.